Paper 2, question 19, and part A, in fact, well, all of them are factorised questions. First one, factorise 6 plus 9x. First stage of factorising, look to see if you can take a common factor. In this case, that's all you can do. Both of those can be divided by 3 is the greatest value you can get. Take that 3 out, 6 divided by 3 you're left with 2, 9x divided by 3 you're left with 3x plus 3x, and that is that factorised. Second one, y squared take away 16. There is no common factor that can be taken out of that. That is known as a difference of two squares, where there is no middle letter term. As a result, what you have here is that both of these brackets contain the same values, except one is a plus and one is a minus. And those values are the square root of the first term and the square root of the last term. The square root of y squared is y, and the square root of 16 is 4. Y plus 4, y minus 4. And lastly, factorise 2p squared, take away p, take away 10. Okay, now with a trinomial like this, what you do is you list the factors of all the factors of the last number. In this case, you have 1 and minus 10, 2 and minus 5, 5 and minus 2, and 10 and minus 1. Normally, that is all you need to do, but because this isn't just a p squared or a y squared or an x squared, there's a 2 involved. When you come to factorise and put this into two brackets, you have a 2p in the first bracket and a p in the second bracket. Now that changes everything, because you don't just add these together to get this. And a clue is, if you do add these, minus 9, minus 3, 3 and 9, none of them match what's there. That's because whatever number goes in here is going to be multiplied by a 2. Now, personally, the way I set out the factors is, I just assume that the first number here is going to be the first one, and the second number here is going to be the second one. Now, as soon as you have that one letter differs from the other, you need to write these factors reverse as well. So, because of the fact that those negatives could be there, they could also be there. So the order is important. So I'm going to rewrite all of these where the first numbers are negatives. Okay, so that's that's covered all options in terms of what goes where. But we still haven't considered the fact that you multiply by 2. The value that I've got here second, which is what I would put in here, I'm going to double all of them, and then you add the values together to figure out whether or not you get this. So saying that again, 1 and minus 10, when you fit it into here, if you just add those together get negative 9, that's not what you have, because one of these values gets doubled. Now you can't just double these two added together, it doesn't work like that. Only those are going to get doubled, assuming these are the ones I placed there. So what I'll do is, every single one of these value pairs here, I'm going to double the second number. So I'm doubling minus 10, doubling minus 5, doubling minus 2 all the way down, and rewriting the factors like so. Now what we do is add these together and see which one works to give us negative p. That gives us minus 19, not going to work. That gives us minus 8, not going to work. That gives us 1, close but not going to work because it's a negative 1. Again, like I said in an earlier question, that means that you're going to actually have the opposite. So if it's not 5 and minus 4, it's going to be minus 5 and 4, as we'll find out later. 10 and negative 2 gives you 8. Negative 1 and 20 gives you 19, minus 2 and 10 gives you 8, minus 5 and 4 gives you minus 1. That's what we want. Minus 1 is going to work here. Now, before we go and jump the gun and throw those in, it isn't that we put in, it's this. Because all we did here in blue is consider the fact that one of the factors, in this case the second one, all of those are doubled. So whilst that is what gives us our answer, minus 5 and 2 in that order are the two values that go in here. 2p take away 5, p plus 2.